Hello, good morning. So today I'm going to have my video report, and my report is about declaration. So again, I'm Elaine Mahandas. So first, let's start with names. A name is a string of characters used to identify some entity in a program. For example, student class, first class. So this example of naming class, naming methods, like this one, like ano pa ba? Ayan, main. So in naming, there are conventions. So these are the example of conventions. In naming, you should not use any special keywords or keywords that is already in the C# language or any language that you use. So in naming a class or methods or anything variables, there are conventions. You can use Pascal casing for class and methods name like this. Camel casing, the camel, for example, capital letter and then another capital letter every word. Do not use Hungarian, like this one, small letter first and then capital. Do not screaming caps. For example, this one are all capital letters. Avoid abbreviations, or this one, user group. Pascal casing. Do not use underscore in identifiers, like this one. So there's a lot of naming conventions like this. Okay. Next are special words. These are used to make programs more readable by naming actions to be performed. They are also used to separate the syntactic entities of programs. So a keyword is a word in a programming language that is special only in a certain context. For example, class, catch, continue, do, try, and event. And there's a lot more keyword. A reserved word is a special word of a programming language that cannot be used as a name, like private, read write, read only, description, public, or sort, or more, like this. These are some of the keywords and special words. Also the data types name, byte, short, int, long, like that. Okay, so next, variables. Okay, a variable is an abstraction of a computer memory cell or collection of cells. A variable can be characterized as a sextuple or of attributes. So it has name, address, value, type, lifetime, and scope. So first, variable attributes, which is name, most common names in programs. Address, memory address with which it is associated. Type determines the range of values the variable can have and the set of operations defined for values of the type. Value, content of the memory cell or cells associated with the variable. Lifetime, time during which a variable resides in a particular location in a computer memory. Scope, range, and or collection of statements where the variable is visible. So these are the examples. So first, let's define that name. So usually we use the variable name, I use the P. Another example, result. So the name is result. We use the type int because it is number, whole number, and then the value of the int result is 0. So that's how you use the type, the name, and the value. For the address, so in this example, a pointer to int p is declared and assigned the address of an integer variable number. So this number. The variable number is initialized as a result of the assignment to asterisk p. So as you can see, the address of the p is in this number. This is how you declare, or this is how to assign the address of a number to a pointer. Okay, this is just an example. I will not run it because it's just an example. So the output, possible output of this value at the location pointed to by p is FFF. The value stored is and blah blah blah. Okay, so this is how you assign the address number. This code, this is the syntax. Okay, oh. And then for the scope, lifetime and scope. Okay, lifetime and scope. So this is a example program again. I will not run it. So we declare initialize there is double v1 value is 10.5, another type is int, name is v2, value is 2, and then the scope is when we said local scope or class level scope, we made a bit of a simplification. It is slightly more complicated than that. Although we're not seeing examples yet, one can define one class inside another class. So we could nest classes very deeply. So the scope of this, the scope of the buttons are this one. Okay, para na inside this class is another class or a method inside a method of a method. So lifetime, each time you click the button, this one button scope click. In the sample, we get a message box showing the result or the value of either any value. So, but usually the truth is we're using a random number generator at lines this one and this one, or line 15 to 16. To throw two dice which we add to the result. So we are not getting random results. Every object and variable in a program has a lifetime. It gets created, so or instantiated at some particular moment in time, and then at some time later time it dies. So kunyari, parang sa looping. Just keep on looping and looping, so the lifetime of it is long. But sometimes, it's not infinite. Meron pa rin naman siyang hangganan. Okay. So, next. Binding. Binding is an association such as between an attribute and an entity or between an operation and a symbol. The time at which a binding takes place is called binding. So, binding. Is this binding? Okay. So, what data binding is the process that establishes a connection between the application and business logic. So, in data binding, a typical use of data binding is to place server or local configuration data into forms or other UI controls. In WPF, this concept is expanded to include the binding of a broad range of properties to a variety of data sources. In WPF also, dependency properties of elements can be found to CLR objects, including ADO.NET objects or objects associated with web services and web properties and XML data. So, in data binding, I lost my data binding. Where is my data binding? Wait. Okay. So, example of codes of data binding is this. So, they use binding, new binding, so to declare a binding process. new bindef.mode binding mode one way. So that the date is the property of time on my data class. So this is how to create a binding. Yeah. Okay, next. So binding of attributes of variables, there are two: static binding and dynamic binding. So static binding occurs before runtime and remains unchanged throughout program execution. So this one is before. And the dynamic binding occurs during runtime or can change in the course of program execution. So the difference of static binding is it is before runtime and it can change unchanged. Dynamic binding is during the runtime and it can be changed. Okay. Variable declarations. Explicit declaration, just like other reporters already told that or explained this about declarations. Explicit declaration statement in a program that lists variable names and specifies that they are a particular type, while implicit declaration means of associating variables with types through default conventions instead of declaration statement. So they use default conventions. While this one is they are particular type. Okay. Lifetime of variables. The lifetime of a variable is the time during which the variable is bound to a specific memory location, just like what I said a while ago. It begins when it is bound to a specific cell and ends when it is unbound from the cell. So, loop na lang loop, but it still has a end. For categories, it has four categories. It has four categories: static, dynamic, explicit heap dynamic, implicit heap dynamic. Type checking is the activity of ensuring that the operands of an operator are of compatible types. A compatible type is one that is either legal for the operator or is allowed under language rules to be implicitly converted by compiler-generated code to a legal type. A type error is a application of an operator to an operand of an inappropriate type. So, usually some programmers use type checking to check if it is compatible. So, if it is not compatible, there will be a type error. Example, this is a program. So, the class program, static void main, so main the value of int I is 100. So to know the type of the full name, type of int name, so we use get type and is. There is, where is it? Okay, is to return true if an instance is in the inheritance tree, and get type gets the runtime type of an instance. So those are the keywords that you use for type checking. Type of operator. Where is it? Type of operator is used to obtain the system type object for a type. It is often used as a parameter or as a variable or field. It is used to perform a compile time lookup. Given a symbol representing a class name, retrieve the type object for it. The getType method again is a virtual method of object. This means given an instance of a class, you can retrieve the exact runtime type of the current instance. Runtime type is the type of an object in the memory. It is therefore a runtime concept. This is the type returned by the getType method. So that is the function of the getType method. Okay, the output will be both the same. So if you run it, okay. Next, type compatibility. So name type compatibility means that two variables have compatible types only if they are in either the same declaration or in declarations that use the same type name. Well, the structure type compatibility means that two variables have compatible types if their types have identical structures. Uh, from the example, our example in type checking, usually we just use the is, where is it? The is to know if the type is compatible, or it it, it returns true if an instance is in the inheritance tree. So if it is false, then it is not compatible. Next, type inference. Type inference allows types of expressions, mostly those of arithmetic nature, can be determined without requiring the programmer to declare specifically the types of variables and or identifiers used in the expression. Type inference. Okay, so the type inference is most of the there are a few kinds of type inference in C#. So, for example, it is implicitly typed local variables, only for local variables, only when the value is assigned as part of the declaration. Value cannot be null, value cannot be a anonymous method or method group, etc., etc. So there are type inference. There are a few main kinds of type inference in C#. So next is scope. The scope, from a while ago, we have a sample program, scope and lifetime. This one, no. Yan. So the scope of the button click is hanggang dito lang. And scope of a program variable is the range of statement in which the variable is visible. So it is only visible in this part. Okay. A variable is visible in a statement if it can be referenced in that statement. Two types of scope: static scoping, dynamic scoping. The static scoping is the scope of the variable can be statically determined, that is prior to execution, while dynamic scoping is based on the calling sequence of subprograms, not on their spatial relationship to each other. Just like the variable declaration, there is explicit, implicit, dynamic, and where are we? Oops. Dynamic and static. Okay. So next is referencing environments. The referencing environment of a statement is the collection of all names that are visible in the statement. And the referring state environment of a statement in a static scope language is the variables declared in its local scope plus the collection of all variables of ancestor scopes that are visible. So static, it is only declared in local scope. The referencing environment of a statement in a dynamic scope language is made up of variables locally declared and all the other variables of other active subprograms at the point of execution. So the declaration is local and the other variables of the active subprograms at the point of execution. Okay. Name constants. A name constant is a variable that is bound to a value only at the time it is bound to storage. Its value cannot be changed by assignment or by an input statement. For example, pag, oops, what happened? Example code or in declaring a constant variable number is equals to 9. So when you put const, the keyword is const, const, the value of this number is equal to 9 and it cannot be changed, so it is locked. Okay. Variable initialization, easy. The binding of a variable to a value at the time it is bound to storage is called initialization. We usually do that. There's a lot of initialization in this program. For example, we initialize the result name. Variable name is result. The type is int and the value is 0. So usually initialization is composed of type, name, and then value. That's how you initialize a variable. Okay, so we're done. I'm going to give all of you a activity that is separately like this one sent to you. So that's all. Thank you for listening. I hope you understand my video report, even though it is not that good. Okay. Color our world with pride. Yeah. Thank you.